Well, good morning. Hope everyone got the room okay. We had a last-minute room change about an hour ago. But my name is Tony Champion, and today we are here to talk about the Windows RT background APIs, specifically what it means for Windows Store app developers. So today the agenda is pretty straightforward. The first thing we're going to do is talk about why we're here. Why talk about these background APIs, why they exist in the first place. And from there, we're going to move on to the bulk of the talk, which is walking through the available background APIs. My goal for you at the end of this talk is to, when you're designing your and architecting your Windows Store apps, is to have a good understanding of where these background APIs fit into the scheme of your app. Have an idea anyway where to start looking at these things and what features are available to you. So from there, we're going to jump right in and talk about why we're here and why we're talking about background APIs. Well, when you talk about Windows 8, since the very beginning, you've heard things words such as proficiency, battery life, performance, and things of that nature. And the Windows team did a great job in revamping Windows 8 to kind of fit that mold. We run on smaller power devices. And Windows 8 overall does a really great job with some of this stuff. But that translates to Windows Store app developers directly, and it changes the way that our apps work. Now, traditionally, your application lifecycle for an app, if you're a desktop developer, is pretty straightforward. The users will launch the app, goes through some startup events, and the app's running. The user uses the app, decides to close it, goes down to close down events, and the app closes. And that's it for your lifecycle. So it's a pretty straightforward process, and most developers truly didn't have to worry about that process too much. Well, things have changed in the Windows Store app world, and we have a little bit more complicated life cycle. To start off with, your app gets launched. Now, this is actually where it starts getting complicated here from the fact of your app can be launched in literally a dozen different ways. Traditionally, the user will go to the start menu, press the tile for your app, and your app will pull up from there. But it could be launched from the search contract, from the share contract. There's really a lot of different ways to go about it. But your app is up and running, and it's on the screen. And as we've seen in 8.1, things have changed a little bit. But for 8, you can have a maximum of 2 apps running on the screen at any given time, the snap view and the full view. But then what happens is the user's using your app, and they switch to another app. And Windows 8, in order to save battery life, will then suspend your app. Now, by suspending it, what it does is it leaves it in memory, and it doesn't change any of that, but it basically pulls it out of the executing pool, which means that your app is no longer working, it's no longer running. Now, as an app developer, there's a good chance that this is where your problems will start, because if your app is not on the screen, it's not doing anything. You do get notified, you get a suspending event that notifies you when this event, when the Windows does suspend your app. And that gives you about 5 seconds to kind of clean up your code and do anything that you need to at that point. Kind of outside of this talk, what this means for you is that you're going to have to start looking at things like incremental saves and things like that. If you're a line of business app developer and you've got this big report or a big form that the user's working on, 5 seconds isn't a lot of time. So you don't really have time to make a bunch of web calls to save off this data and do a bunch of stuff with it. You need to be able to handle it quickly. So you have to change your architecture to reflect that. If the user comes back to your app, then you get a resuming event fires, and then your app comes out of, still stays in memory, but will begin executing again. Now, the next step that really starts to mess with you is if your app is suspended and the performance starts running low or memory starts running out of the machine, then Windows can terminate your app. You don't get notified of this event, it just simply terminates it. The other approach is the user actually has the ability to close the app as well. And it will go through the suspension process and then close after that. But what this means for you is that the user could be using your app, switch away to another app. Sometime during the process, Windows can terminate your app, and when the user comes back to your app, it's actually starting fresh. Now, for the user, this is a bad experience because the user doesn't understand all of this. And so as an application developer, you're really going to have to spend time to consider this workflow. And even, again, outside of this talk, you really need to have a decent understanding of this workflow when you design your apps. But what this means for us, as far as for background tasks, is this affects a lot of different type of apps. The first is apps like SkyDrive. Right? So if I have an app that I want to upload to SkyDrive, a file, and it's a large file, and I tell the SkyDrive app I want to upload it, and say it's going to take 10 minutes to upload. So I go off and I do some other things in a different app. When I come back 20 minutes later, I expect it to be done. I don't expect it to be at the 9-minute, 50-second mark because the app got suspended as soon as I switched away from the app. The next is music. Listen to music all the time while I code, but I don't want to eat up valuable screen real estate to leave my music player on my screen. I want to be able to open up my music app, play music, put it in the background, and still hear my music playing. But if your app is suspended, as soon as you switch away from it, your music will stop and you lose that experience. And finally, real-time communications, the same thing, Skype. I have Skype on, communicate with my employees, my clients all the time. Do I want to eat up real estate by having Skype on the screen? Of course not. You want to be informed whenever a new message comes in so you can interact with it at the time. But if I switch away from the app and you're doing something else, if Skype is no longer working, then that doesn't do me any good. Now you translate over that into LOB apps, it's kind of the same type of scenarios. Real-time communications. If you have an app that's talking to it's got a socket connection open, it's pulling real-time data in. User switches away from your app, that connection closes. Same thing with file transfers. If you're pulling down a lot of data, do some analysis for it for your users. Again, as soon as you tell the user that it's going to take a few minutes to pull all this data in, they most likely will switch over to another app, do some stuff and come back and expect that that process is still going. Or if you do periodic updates, you're updating sales information or whatever the case might be. Again, if the user's not looking at your app, the user still expects all that to keep working. And it's an expectation from the user that you really have to meet. But along with those challenges of the application lifecycle, the background APIs actually open up a lot of opportunities for developers. And this is kind of where we're going to talk about with connecting with your device. Overall, users are expecting more from your applications now, right? They're expecting your applications to be always on, to be a part of everything that's going on with them. And it's driven from things like live tiles and toast notifications and stuff. And so the user's interacting with your app without ever starting your app. Well, that carries over into the development space by you have to prepare for some of that. And some of the things like live tile updates and toast, we can schedule and use the API to do that. But there's also another set of this and of these background APIs that allow us to really know what's going on with the machine and interact with the user accordingly. For instance, when the user logs on, if the user logs on to the machine, I might want to update my live tile or send a toast notification, letting them know that they have new email messages or they have an actionable item that they need to take care of. Or the classic example with the internet's available. Your user's working on the machine offline, on an airplane. When they get to the airport, come back on, do you really want the user to have to open your app so your app can say, hey, look, I have an internet connection, let's sync up data? The better experience is as soon as the device has internet access, that your app automatically is notified of this and then can sync data up and update the user with the new data. And other things like time zone changes. If you've got a scheduling app that needs to update scheduling appointments based on a time zone change. Again, if you're doing notifications on your on live tiles, something like this is a good opportunity for you to do this without the user ever having to open up your app and interact with your app. So with that, let's jump into the background APIs. And what we're going to do is we're going to talk about 3 categories of background APIs today. And the first is just playing audio and video. Typically, for most of this talk, the examples and stuff will be XAML basic examples. But there are some things that I wanted to point out. If you are a developer, you've always heard that there is pretty much parity between XAML and HTML when you're developing native apps. And for the most part, that's true. When you start getting to this, background APIs and such, there are some edge cases, and we'll talk about a couple of those. And the first is when you do audio and video, they're done slightly differently. In the XAML world, you use a media element for everything. You use it for the video, you use it for the audio, whether you're playing straight music, if you're doing sound effects, whatever the case might be, you typically will use a media element. In the HTML world, you're going to use the HTML5 tags or the audio and video. A slight difference, but it is a difference between the two stacks. Now, if you're going to play audio that play in the background, you have 3 requirements that your app must meet. The first is you have to add a declaration to it. You have to tell Windows Store that you want to be able to play audio in the background. You do that by adding a background declaration and select the audio type. For XAML-based development, the entry point just needs to be the main entry point of your app, which typically is the name of the solution, .app, which is the default app class. If you change that, you need to reflect that accordingly in your declaration. Secondly, when it comes to audio inside of a Windows Store app, there's about 8 or 9 different categories audio categories you can choose from. But there's only 2 categories that are supported to play background audio. The first, and which is typically used, is the background capable media. And this is what you're going to use for things like your audio playback, your video, any type of thing like that you're going to want to play across the speakers when the user's not on your app. The second is the communications. And this is for real-time chats, voice over IP, and things of that nature. And the difference is if you have a Bluetooth-connected device, then instead of playing the audio through the speakers, it will play the audio through the Bluetooth-connected device. So if the user is using any type of headset or anything like that, and you want to play your audio through that, you use the communications protocol. Setting your audio category is pretty straightforward. In XAML, it's enum. In HTML, we're just adding a Microsoft-defined attribute onto our audio tags, or our video tags, done the same way. But it's done a little bit differently between the two. And third, you need to register for transport controls. So if I've got audio playing in the background, I still need to do things like pause the audio, change the volume of it, maybe change tracks, things of that. And to facilitate that, Windows provides what's called immediate transport controls. And these transport controls will show up on your screen whenever you push any of the hardware buttons. So you change the volume on your machine, or you hit, if you've got play, pause, hardware controls, if you push those, immediate control will show up in the upper left corner of your screen. And it's got things like play and pause, tracks, change the sound level, and some audio information, thumbnail, and things like that. But you have to register for those before your app can play audio in the background. And you do that by using a static class and in the Windows Media namespace called Media Control. And this Media Control object has a collection of events. For all the features we saw, there's an event attached to it. To register for it, all you're actually doing is adding event handlers to each one of these events. Now, I show these 4 up here because these are the minimum 4 that you have to attach an event handler to in order for your audio to play in the background. You miss one of them and your audio won't play. And it's pretty straightforward. It's the play, pause, and stop. What we're going to do is we're going to jump over and we'll take a quick look at this. All right, so I've got an app here. And as you can see, in our package app manifest, we've declared an audio background task. On our main page, I have a media element here that we're playing an MP3 through. If you look at the code behind, here's where I use here's where I've gone through and I've attached all my events to my media control. Now the media control has it is playing property, and it's a manual property you have to set. It doesn't automatically detect that, so you do have to set that. And then I handle the events, which all my events are really doing is updating my UI from the media control. Now, the media transport controls. Now, the other thing that needs to be pointed out is the media control, it doesn't actually affect your audio or your video at all. So when the user pushes pause, it will fire the event, and it's up to you to actually pause the audio. So you do need to make sure that you wire that up correctly, or the user will have a poor experience. If you run this, all right, so we have audio playing. And if I switch over to another app, and I push one of my hardware controls here, you'll see we've got our transport controls will show up in the background, or up in the top left corner. Now there are other things you can do with this media control element. Like you can set you have control over the artist name, track name. Again, you can add thumbnails. It doesn't give you a lot, and there is no way to actually override it to change the styling of it, but there are those few that you can take advantage of. You see now we've got a little bit more information provided to the user. All right, so the next one I wanted to talk about is transferring data. This is transferring large sets of data up and down from uploading and downloading. Typically, you don't want to talk about this unless you're talking about transfers that might take more than 20 or 30 seconds, depending on the size and your bandwidth. If you do have a large set of file, there is some background transfer APIs available to you. And basically what this does is it moves the actual transfer of the files outside of your app. So that way, it's still working whether your app is suspended or even terminated. And then as it's doing its work, when the user comes back to your app or restarts your app, whatever the case might be, then there is at that point they can receive all the notifications of everything that's going on. So you can have your app downloading a lot of information in the background. The user can go off and do whatever they want to. When they come back, you can catch up your UI on what's happening, what the current status is, the current progress, all that kind of information. There are multiple protocols that are supported for the background transfer APIs. You can upload and download for HTTP and HTTPS, and you can currently download with FTP as well. There are several authentication schemes that are supported. The first is your basic server credentials, your username and password. If you've got any kind of proxy credentials, you can pass that. If you're using any kind of cookies, you can pass that, handle those as well. And then finally, you can use any kind of custom HTTP headers that you need to use. One of the other great things about the background transfer APIs is that they're efficient. And they're designed for battery efficiency, so they work very well with the device. And the other part of that is that they're pretty smart when it comes to the network. So if your network has a hiccup and goes offline for a little bit, the any background downloads or uploads that you have going on will automatically reconnect after the network status comes back up. And the other thing it's got is a cost policy. So we are talking about mobile devices and tablets and stuff like that, which could very well be on things like wireless carrier networks or mobile carrier networks. And by default, background transfer APIs won't work. It won't actually push or pull data if you are on some type of a meter network. But you have the ability to change that based on how you set the cost policy. So this will help prevent your users from really chewing up their bandwidth if they're having to pay for it. So when we talk about these, look at in a little bit more detail, I'm going to be talking about the downloading aspect of it. But everything I talk about, there is a corresponding uploading as well. You begin with a background downloader class. And from that, you basically tell it, hey, look, I want to download this file, and I want to put it here on my system. it returns a download operation. The download operation is typically what you're going to use for mostly in your app. And from this download operation, you're going to be able to do things like, be kept informed of the progress, completion or erroring that happens, and it also gives you some control. So if you do need to pause or restart the downloads, you have control of it that way. Creating this is pretty straightforward. You usually you create a background downloader object. Again, you tell it what you want to download, where you want to download it, and you fire off the async command of start. Now, if your app does, when you create that, you get that download operation that, as I said, you can attach to. But if your app does terminate during the process, when the app restarts, you want to be able to connect with all those operations that you currently have. And you can use that with an with a static operation called get current downloads. And what this does is it returns all of the download operations that you currently have running for that app. And again, there's a corresponding upload with this. Once you get that collection, then there's an attach command that you have to fire off and for each one of those download operations. And once you do that, then basically it refires up all the events, and then at that point you can wire into all of them. The last one I want to talk about is background task. And this is where most of your work is going to end up being if you're an application developer. So background task is nothing more than a small block of code that's going to run outside of your app. And it's going to run in response to some type of system event that's going on. It will run if your app is either suspended or terminated, so you don't have to worry about that. But the other cool thing about it is your app never has to be started. So say I have the earlier example, with the internet availability example. If the user's started my app, I've registered for that event, so now my app's going to know when the internet becomes available. The user shuts down the machine, restarts it. The next time when the internet's available, my app will already know. So the user never has to start your app after you've registered everything for you to be able to be aware of this. So again, you can provide a great experience to your users by updating live tiles, sending toast notifications, doing whatever you need to do, and they've never had any direct interaction with your app. We'll see in a little bit here that this gets reinforced, but you do need to remember this is a background process. We are talking about Windows 8, and we are, the reasons these things exist is because we're looking at power life and efficiency and stuff. So when you create these things, they need to be very small, very short, and they don't need to do a whole lot of work in the background. You can't talk about background tasks without talking about the lock screen. And if you're unfamiliar with a lock screen, your app has a lock screen to where the user can add apps to it and provide feedback on the lock screen to the user. You can have up to 7 of them on your device. But outside of that, what this is doing is this allows Windows to determine that the user wants these apps on the lock screen. So the user likes these apps a little bit, and the user basically gives me permission to run in a little bit higher state because this is an important app to the user. This has a very direct correlation with background task. And some of the things that you get if your app is running on the lock screen is you can have background tasks that run longer. You can use more resources. You have access to more network resources. You can call them more frequently. And you have a lot more opportunities. And we'll see the list difference here, but there's quite a significant list of things that your app can do if it's on the lock screen versus when it's not. Luckily, as far as when it comes to adding your app to the lock screen, you can do it in code. There is a request access async method that you can call when the user starts up your app. And if the app is not on the lock screen, it will prompt the user if they want to add the app to the lock screen. And then it will do it automatically. So you're not relying on the user to go to the settings and add the app manually. Now, the catch with this is that it can only be called once per app. So the first time the user runs the app, you ask, they put it on the lock screen. The user comes back at a later date, manually removes it from the lock screen. You can't go back and ask them again. This call won't produce as UI again. It will simply fail on you. So you do need to be very vigilant when you're doing your coding and to determine if your app needs to be on the lock screen, to do checks to see if it is. And there is APIs available for that. You do have some quotas that you need to adhere to. If CPU usage, again, I said it, I did mention that it was small chunks of code, and this will tell you how small. If your app is not on the lock screen, you get a whole 1 second of CPU time to complete your background task. If it's on the lock screen, you get 2 seconds. Not a lot more, but it is doubling it. And the refresh time, how often your event can fire, when we're talking about time-based events, if it's not on the lock screen, it's every 2 hours. If it is, it's 15 minutes. So this starts to show there's a significant difference between the two statuses. And you also have network quotas as well when the app is on battery power. And this is, again, for performance and efficiency. If you are on battery power, basically your bandwidth is metered throughout the day. If you're not on the lock screen, you get 7.5 megs. If you are, you get 45 megs. And again, this is metered throughout the day, so you can't download all 45 megs in a 15-minute period. These numbers are based on a 1 megabit throughput, so they scale accordingly. If you're on a faster internet connection, running 10 megabits a second, then these numbers go up tenfold. If you're on a slower, connection, these will drop back accordingly. And all these quotas only work if you're on battery power and also if the app is not running. If the user is actually using your app at the time, then Windows basically assumes the user is okaying your app to run, and any background processes you have won't be subject to any quotas. Now, each background task has a single trigger, something that fires it off. And we're going to talk about 5 triggers today. First one's a control channel, which is your real-time communications, your socket communications, and that type of thing. Push notification, if you're using the Windows push notification services. A maintenance and a timer, which are your 2 time-based triggers. And then your system event, which is kind of a catch-all of things of what's going on in the device. And now out of this list, just to start talking about the lock screen a little bit, and you'll hear me talk about that a lot, control channel, push notification, timer, and some of the system events all require your app to be on the lock screen. So again, you can already start to see that this is going to play a big role in your design. You also have conditions. And you can have multiple conditions, and really the conditions for your app is really about efficiency. If your trigger requires internet access, then you can set a condition that says, hey, the internet has to be available for my background task to run. There's no sense of your background task running if it's going to fail. You have the conditions that are available are you can check to see if the internet's available or if it's not, if the session's connected or it's not, and if the user's present or not. Again, if the user's not present and you're going to post a toast notification, do you really need to send that toast notification if they're not even at the machine? So these are the things that you can add these, and this just helps Windows run more efficiently. If you're going to add background tasks to your applications, there are a few things that you need to be aware of. First, again, we come back to our friend the app manifest. And you have to declare a background task declaration for each background task that you're using. A while ago, we used the audio. The rest of them are for your background task. Now, as it shows here, you can use the same background task for multiple triggers. You don't have to create another class for each trigger you want to fire. So here, if you're using a background and each background task only has to be registered once, so you can kind of group anything that their task has to do, you can assign it through here. The entry point is the actual full name of the class that you're implementing, namespace, and including the namespace. The next is all your background tasks have to exist in a Windows runtime component. They cannot exist in your main app. They can't exist in a class library. It has to be a Windows runtime component. So in your solution, you'll need to add a Windows runtime component to hold all your background task classes. And lastly, which actually trips up a lot of people, and it tripped up me the first time I did it, and I knew better because I was actually writing an article on it at the time, is that you have to have a reference to the Windows Runtime Component library you have from your app. If you don't have that reference, it will not register the app. Now, traditionally, developers, if you're a XAML developer or any type of managed code developer, you look at this and you're like, well, it's a no-brainer. The app won't compile if I don't have that reference there. Well, it turns out that when we register our background tasks, we're never actually creating an instance of the class. Therefore, you get no compile time errors. So your app will compile and it will run, and just simply fail to register your background task and never notify you of it unless this reference is there. Now, when you define the background task, first thing to note is that all your classes will be sealed, and this is not a background task thing. This is any class that you have inside of a Windows Runtime library has to be sealed. And your class will implement the iBackground task interface. Now, this and all the background task classes and enums and all that are all found in the Windows Application Model Background namespace. And the iBackground task interface has a single method, a run method. And that run method, it passes a task instance, which is the process that's actually running your background task, so you can interact with that. And that's about as complicated as the actual background task get. If you're running an async operation, you're going to make a web call or something along those lines. The thing you need to know is that the process that runs your task will not wait. Right? It spins up, it calls the run method in your task, and once the run method returns, that task process terminates. So if you're making an asynchronous call, it's not going to wait around. To get it to wait around, what you have to do is request a deferral from the instance. And all this deferral is doing is telling your instance to hold on, to wait for me, I'm doing something, and I'll let you know when I'm done. Now you're still limited, you still have your same CPU quotas, but while you're waiting for something to download, you're not chewing up your CPU usage. So you call the deferral, you do make your web calls, do whatever you need to do, and you do need to make sure you clean it up by calling the complete method on that deferral so that you can release that task instance. Now, defining the background task is pretty straightforward. We use a background task builder, and the sole job of the background task builder is to take all the pieces, put them together, and register the task with Windows. You have to do things like set the name. Name has to be unique for each background task that you're registering, each instance of it. So if you're going to register a background task for multiple events, that your name needs to be unique. Now, it doesn't have to be unique across the entire device, just unique inside your app. You set the task entry point, which is the full name of your class. And here, as you can see, you never actually are calling an instance of your class. So if you don't have that reference I mentioned earlier, this code right here will compile, it will run, and it will actually just fail to register your background task, and it'll never fire. You add any triggers and conditions that you need to set, and then you register it. And at that point, it's tied to your app, but it's running inside of the Windows background processor. Now, inside of your app, if you want to have access to any background tasks that you have registered, you can do that there's a static collection, the background task registration class of all tasks. Calling this method will return a collection of all the background operations that you have, and from there you can do things like remove them, check statuses. There are events that you can fire off to know when it runs and when they complete. You can do all that through this all task class. So with that, let's walk through a simple setup. So again, we've created I have a project. I've created a background task for a system event, and here I've called it, the namespace is background task update task. you can see here that I've added a new project a Windows Runtime component. I have a single class that's update task in it, and I do have my reference set from my main app into it to that new project. The background task is pretty straightforward. It basically is just setting a local settings value of when it runs. If you come over to our main page, pretty simple UI that's basically displaying that value that gets set. Now in our code, whenever the page loads up, what it's doing here since it's a demo, what we'll do is we go through and we register any background tasks that are previously registered. You don't have to do this in your app. Once you've registered it once, you don't need to go through and remove and add it. It will stay there. Then we use the builder and we create a maintenance trigger, which is a time-based trigger. We tell it to run every 15 minutes. And all your triggers are going to have a one-shot property at the end of it, basically to let you know if are you going to run this once or you want it to run multiple times. We set a name, we set the entry point, and we register it. And here when we get our background operation here, we've registered the completed, so we know that when it's completed, it will fire off our UI. And we update our UI. Now, one of the things that if you are using any type of background task, this works for the audio as well, is that you need to remember this is running in a different, if you wired up the media control events, or here when we're wiring up to a background task, they're running in a separate thread. So if you're going to update your UI for any reason, you have to use the dispatcher to run that to basically tie in your threads, or else you get a runtime error. So we go through and we run this app, and again we have basically a simple time-based trigger. That last time it ran was 3:42 a.m. This machine is still set to Houston time, and so it ran here not too terribly long ago. And that is all you really have to have to add a background task to your project. Now, getting back to the triggers, we are going to talk about, as I said, 5 sets of triggers. And the first one I want to talk about is the control channel. Now, I've got a lock at the bottom corner of this because it needs to be on the lock screen. You'll see this, all the triggers, which ones need to be on the lock screen and which ones aren't. And a control channel is really for real-time communications, for any type of socket communications or anything like that you have up and running that you're wanting to maintain that. If you're using a control channel trigger, when it runs your code and it's running this connection in the background, it's running it in a minimum power state. So it's more efficient and it doesn't eat up battery device resources. Now here's one of these edge cases I talked about earlier. The control channel will not work inside for JavaScript, and it won't work at all. You can't add a C# Windows Runtime component library into your class and call into it that way. If the Windows Store app is a JavaScript-based app, you can't add a control channel to it. And there's 2 different types of control channel triggers that we really talk about. It works in 2 categories. The first is a push notification, and the next is a keep alive. Now, the push notifications is kind of a bad name for it. This has nothing to do with push notification services. This is more of a way of handling data as it comes down the pipe. And really, this is set up for kind of low-frequency type data. So if you've got a real-time, you've got a socket connection that just basically pushes data every once in a while to your app, this is a great solution for it. Again, it will run, you can configure it to run at a very low-powered state, and it will actually run pretty close to your network hardware on your device. And it's great for performance, for battery life. And it will keep this channel open and receive data every time it comes in. So even if the app gets suspended or it gets terminated, your app can still be receiving data. The other is the keep alives, and this kind of breaks down into 2 different categories as well. First is the server keep alive, and this is basically the scenario where you need to ping the server every once in a while to keep the connection open. Things like mail servers and stuff like that. You can use this to regularly ping it just to make sure that that connection is maintained. And it's really to avoid your timeouts. Now you can set the frequency between this for between 15 minutes and 24 hours. It will run every time period. And you're going to see this 15 minutes a lot. In fact, you've already seen it if you looked at if you remember the quotas we talked about earlier. And one of the things to know about Windows and this 15 minutes is that there's a process, and you'll see this with your toast and tile notifications if you're trying to schedule those as well. There's a background process that runs every 15 minutes inside of Windows. And what it does is it takes all the background tasks, all the scheduled tile notifications, all that kind of stuff, and it'll run it. That's why you have this 15-minute time window here. You can't set it to run every 5 minutes because that background process only fires off every 15 minutes. The other thing that shows up with that, especially in your time-based triggers, is that it runs when it runs. You have no control over when it runs. So if I schedule a time-based event to run every 15 minutes, it might run 15 minutes from now the first time, or it might run 2 minutes from now. It just depends where that background process is in its cycle. So when you're developing your apps and you're testing this stuff, if you see it firing off not when you expect it to, that's the reason why. Now the other is the network keep alive, and this is really something that Windows takes care of for you, and this is to handle proxies and IP translators. The time period that it will ping the connection is determined by Windows. We have no control over that. The only control you have is that if you are finding you're still receiving timeouts and stuff, there's a method you can call. You can ask Windows to maybe ping a little bit faster. But again, you have no control over actually how often that happens. You can just request that Windows does that a little quicker. Now the second is push notification, and this does talk about Windows notification services. If you're unfamiliar with Windows notification services, it's a great tool to push data to your client from the server. High level, what happens is your app registers for a unique address with Windows notification servers, tells your server what the address is, and then the server can use the Windows notification server to push data down to your client. Now there's 3 types of data that you can push. You can push a tile update, push toast notification, or you can push raw data. If you're doing tile or toast, you don't have to worry about the background task process. There's other setups you do in your Windows Store apps, and it just kind of gets handled for you. But if you're doing raw data, you need to use this type of trigger. Now you're limited to a 5K message, so you can't send a ton of data down through this. But that's okay, because typically that's not the use case you're going to want to look at. And you are talking about sending data through a public service. So if you're talking about a line of business app or something like that, you need to be very cautious of that. If the user has a new confidential email, you don't want to send that through the push notifications. Instead of what you're going to do is you're going to send, you'll go kind of more of a command route, and you'll send a command notification through push notifications that says, hey, look, you have something new you need to go check out. Your app will open, then your app can securely go out and get that data without going through a public service. The only gotcha to this is that in order to use push Windows notification services, your app has to be registered in the Windows Store. So if you're building a line of business app that you are planning on sideloading, you cannot use this currently. If that changes or not, I don't know, but that is a limitation that you currently face. And some of your use cases for your push notification, really, as I said, it's to send over some type of action. So things like if there's a new email available, you have incoming communication. If you're building an instant messaging client, you can, instead of requiring the app to be on, you can actually just send a notification to the client that they have a new incoming message. You use things like use it to tell the user they need to sync up data. Any type of stuff like that. The next 2 I want to talk about together, time and maintenance, because they both are time recurring triggers. And in fact, if you look at the APIs are pretty much identical for them. They can be set to 15-minute intervals, again, on that background process that we have running. And there's two types. The first is a time trigger. And if you're going to use a time trigger, your app must be on the lock screen to run. The other is a maintenance trigger, and the only requirement there, it doesn't have to be on lock screen, but your device actually has to be plugged into AC power. So if you're running on battery mode, your maintenance trigger will never run. Both of these can be set to that 15-minute interval, but you do need to also remember that if you're running a maintenance trigger and your app is not on the lock screen, then you're back down to that refresh quota that I mentioned earlier, and you can only run it every 2 hours. And the last one is the system event. And this is really a trigger that responds to something that's going on in the system. And there's currently 12 events that it can track. Things like if the internet's available, if your control channel is reset, if you lose connection on your control channel trigger and it has to reconnect, you can be notified. The user is at the machine. Servicing complete is if your app gets updated and you need to go through and you need to re-update some background task after the app gets updated. Out of these, you'll see there are several that require the app to be on the lock screen to be able to use. The last two I want to point out here is that there is this lock screen application added and removed task. So if you are developing an app that requires background task and uses background task and it requires the lock screen, you still have to consider the user experience and what happens if the user does not put your app on the lock screen. And you might have two completely different workflows of how your app works in the background based off if it's on the lock screen or not. If you're going to do that, you have these two classes, these two events that you can register for, and you can change your workflow based off of the user's added it or removed it from the screen. All right, so let's take a look at that in action. So what I've created here is an application that notifies me of when there's a status change for my network. You see here in the run instance, basically all we're doing is we're doing an update. And when it fires, we check with the network information, we get the current connection profile, and then we figure out if we're online or not and what the current status is. Now, for the demo, this is a simple demo of letting you know to kind of update our live tile and to send a toast notification if our network has connected or not. To further this along, if you're talking about an LOB app that requires your communications through a VPN, your VPN is, if it's you're using the Microsoft VPN client, registers as a network device on your machine. So when the user connects to your VPN, this trigger will fire off. You can find out that your user is actually connected to the VPN, and then it can start communicating. And you don't have to use kind of a trial and error method of just hitting whatever service you're trying to hit, and if it fails, then you try again later. You can be notified when that type of stuff goes on. Again, similar to our last one, it's a pretty straightforward process. With the only real difference here is that when we set our trigger, we're doing a system trigger. When we have a system trigger type, which is an enum that goes to that list that we just talked about. Now we run this, and I'm currently on the network here. And if we come over here and we unplug our device, all goes well. We get our UI updates, but we get a toast notification to let us know something is going on. And we come over here, and our live tile updates. So with very little code, you now have a very system-aware app that lets you know what's going on. Now this carries over to the fact that the app does not have to be running for this to happen. Right? Anytime there's a network status change, that live tile will update to let me know what's going on. You can further that at that point, if you've got internet access or if your VPN's connected, your app can still work and still do stuff, and the user never actually has to start your app. I want to talk a little bit about debugging when it comes to background tasks, because it is a little different, because you are talking about a process running outside of your app. Now, when you're starting to debug, the first thing you need to always look at if your background task is not firing is the naming. We use this name in 3 places. You can define your background task. You have obviously you have a namespace and a class name. Then when you go to your app manifest, you put that full namespace and class name in the entry point. Then finally, you call it when you register your task. All these 3 need to match up for your background task to be registered properly. If you're developing background tasks, testing them can sometimes be a challenge. If you have a maintenance trigger that's going to fire every 15 minutes, do you really want to start up your app and wait 15 minutes to be able to test your trigger? Well, luckily, whenever you run a Windows Store app from the debugger in Visual Studio, there's a debug location toolbar that fires up. And in this toolbar, it has a suspend drop-down. Now, outside of background tasks, this is very useful if you are when you start talking about the application lifecycle to test your suspension and your resuming and even your suspension and shutdown of your app to make sure that any incremental saving or any type of workflow that you need to have in there works. You can use this suspend drop-down. But in addition to that, any background task that you register for your app will show up here in the suspend drop-down. And then you can use this drop-down, you can select your app and basically manually trigger your background task. Now this works for all of them except for the control channel, the push notification, and the SMS received system event. And that's because these 3 require data, right? I mean, you can't just use a drop-down box and simulate a push notification being delivered to your app. So those 3 won't work in this manner. If you're doing background task development, there is some event viewers that really help you keep track of what's going on. One's the background task infrastructure inside the Microsoft Windows folder, and the other is apps. And actually, this apps is very useful if you're doing any type of Windows Store app development. If you want to know what's firing off and what's erroring your app, this is a place to look. Now, by default, you get the operational logs are available, so you get any of your fatal errors and things of that will show up in there. But there's actually a lot of information that gets logged in the diagnostics logs. So if you want to enable those for your development purposes, it's a pretty straightforward process. You go to your log, you go to the view, tell it to show analytic and debug logs. It will add that debug log on it. And then you have to go in and you actually enable that log. Now, a word of advice is that diagnostics log, especially if you start talking about a bunch of apps that are firing quite often, grows quickly, and there's a lot of stuff going on there. So if you're going to enable it for debugging testing, I would advise you to turn it off when you're done your debugging. But there is a lot of great information that's provided there. And actually, we're going to jump over here and show you. We come back to our original task that's still running. We come back to our time-based task. You'll see, we put a breakpoint here. In our drop-down, you'll see that our update task has been added here. Firing it, we'll call our breakpoint. And it's really that simple to do your debugging. Now, everyone here should know that Windows 8.1 came out this week, and they did want to go through and talk about what that means for the background task, because it actually means quite a bit when it comes to some of the capabilities and features that you have. And first, as far as what's new from a high level, currently we have no breaking changes. And I put this for now, and we'll see when it comes to audio playback that in 8.1 there's no breaking changes, but there is a change you'll have to make that's not guaranteed to run past 8.1. But all your background tasks that you develop for Windows 8 will run with no issues on 8.1. You get the same CPU and network quotas. That does not change. You do have a change when it comes to lock screen apps. So you still have 7 apps that you can add to your lock screen, but 8.1 presets 3 of those for dedicated apps. You have a mail app, you have a details app, which allows that app's allowed to show more information on your lock screen, and then you have a new alarm app. What that means for you is that there's only 4 slots left in lock screen apps, which means that the odds of your app being on the lock screen have dropped. So you do need to take that in consideration if you are looking at building something that needs to be on the lock screen. And there's a new concept of a background work cost. And what this does, you've got that background process that runs every 15 minutes that updates these things. And anytime you fire off one of your background tasks, you can check to see what the current workload is on that background process. And it returns a value of normal, low, or high. And so if the background cost is high, you can choose not to run your background task if it's not an important task. And again, this comes back to the user experience and providing efficiency, battery proficiency, and that type of thing. And then you also, for your background tasks, the ability has been added to cancel them. Currently, you can remove them, but this gives you a chance to, if you have tasks that have locked up or they're just running too long and for whatever reason you need to cancel that process, you now have the ability from your app to cancel them. I want to go through those 3 apps that three types we talked about real quick. The first, audio and video, and it largely stays the same, with the exception of that media control, right? So we have that system transport control that we wire into. And this still works, but this is your change for 8.1. It will work in 8.1, but after that, it's basically going away. And it's being replaced by system media transport controls. So if you have 8.1, you have an existing app that uses background audio, you'll notice that it will run, but the transport controls look slightly different when they appear on the screen. This is because the layout's been changed a little bit to accommodate some more features. You now can do things like channel changing if you're doing any type of radio or that type of thing. The record, fast forward, and rewind buttons have been added in there as well. So you've got a few more things that you can wire in and a few more interactions you can have with your user. When it comes to background transfers, they've been made a little bit more efficient. One of the features that's in there is auto switching. So if you have a background task that can be resumable, and, it can be paused and then resumed, if a more preferred network becomes available, the background task will automatically switch. So if you are on a metered network and then you switch over to an unrestricted network, it will automatically switch for you. Or if you're on wireless and it's running slow and you plug your machine in, it will automatically switch that background process over to the faster network for you. And then you also get the ability to directly from the background transfer update a toast or your live tile for your app when it's either it's successfully completed or it failed. So instead of having to try to wire that in and we're waiting until your app gets restarted to notify the user, you can directly notify the user from the background transfer API. There is also a new concept of groups. And what the group does is allows you to take a group of downloads and do a couple things. You can set the transfer behavior. You can tell it if you want to download them all at once, if you want to serialize it and do it one at a time. And then you can also set the priority of these. So if you are doing something like downloading a bunch of episodes to a TV series, if you can set the priority for the first episode higher so that Windows will download that one first. The user has it, can start watching the video while the rest are being downloaded in the background. You can have multiple groups, manage them however you need to. System event triggers, all the ones we talked about are still there. None of the APIs changed for them. All the conditions are exactly the same as they were. You have the same 6. But you did get 2 new trigger types we'll talk about here in a second. For the system event, you've got the background work cost. So we talked about that new concept of the background work cost. Well, instead of having to check that work cost whenever your background task runs to see if you want to complete it, you can change your workflow around the change of this background work cost. So if the cost gets elevated, you can turn off some of your background tasks. They'll never fire. Or if it drops down lower, you can add additional background tasks as you need to. The other is the NFC state change. This is done to support NFC, so your app actually does not have to be running to be wired into NFC event on the machine, which opens up a lot of possibilities for your apps. And then we got a couple of new triggers, and these are both have to do with device interaction. So one of the new things that we got with Windows 8.1 is the ability to communicate directly with a Bluetooth device or USB device or some type of device that's connected to your machine. Well, to support this, there's 2 different triggers that were added to the background task. These triggers are not throttled. They're not bound by the resources that we talked about earlier. They run at a lower priority, so they don't take up as much CPU utilization, but they have no limits. They can run as far as CPU usage or network usage, that type of thing. There's also no frequency restrictions. You can run them as often as you need to, but you can only run it one at a time. And there's 2 different triggers we'll look at, and you can only run one of them at a time. You can't have one of each going. And this is largely to do with the fact that since you're talking with communicating directly with a device, you don't need to have 2 processes going at a single time trying to compete with each other with the device. And these are the only triggers that can actually be manually triggered by your code. If you've noticed that all the triggers we've talked about to this point are all scheduled triggers, right? It's either going to run on a certain time interval, or it's going to respond to a system event or something like that. These are the only 2 that can be fired manually. In fact, they have to be fired manually. You cannot schedule these things to run. The user has to be using your app. Your app has to be in the foreground to fire these things off. They can be fired off, and then after that, if your app goes in the background and gets suspended or terminated, the process will continue to run. But it does need to be triggered while the user is sitting in front of it. And as I said, there's 2 different types. The first is the device use trigger. And this is basically for things just like syncing operations, pulling and pushing data to your device. You have 10 minutes clock time, wall clock time, which means it's not CPU time. As soon as it started, it has 10 minutes to finish. And the device has to remain connected during those 10 minutes or however long it takes your process to finish. If your device gets disconnected at some point during it, the process will fail. And this needs one-time approval. So the first time you run this, you have to ask permission from the user, and you'll get a UI very similar to the UI that you get when you ask permission to add your app to the lock screen, if your app can use it. Now, once you get permission from the user, then you're allowed to use it, and there will be a permission setting that the user can go to remove that access if they need to later on. The other is the device servicing trigger, and this is for doing basically flushes of code and stuff like that to your device. You get 30 minutes of wall clock time versus your 10, and the device can be disconnected. So if your process needs to reboot the device after updating the code on it, you're able to do that, and this process will wait for it can wait for it to connect and continue on. The difference is you need approval each time this runs. So every time you're going to fire this off, the user will be notified. The user has to okay it for it to continue. This typically is not a big deal because this is very seldom you're going to find yourself really needing to use this. So to wrap up quickly, there's some things I just wanted to kind of bring to your attention. And really, the first is to be considerate of system resources, right? The whole reason these background APIs exist is because Windows 8 was developed to be efficient and to perform well for the user. If you go and use these background APIs to shortchange that and just use them for everything, then you're basically going against the whole design of Windows 8. And if you, especially, if you are building consumer apps, this can, directly affect your app because if your app, the user has your app installed, your app is constantly running and churning up and killing battery life, then the user has a bad experience with the device. There's no idea that it's your app that's causing the problem, but the user has a bad experience. The user has a bad experience with the device, doesn't use the device, they're not using your app, and you're not making money. So it does directly affect you, so be considerate. And some of the things you need to do is ask yourself, do you really need to use background APIs? Now, hopefully you do, and that's why you're in this talk, but you need to look at that. Case in point, I do oil and gas work, and we had some apps that we were migrating over to Windows Store apps, and we had some charting components that in the previous version, every 10 minutes it would go out and it would update some well status locations of all the wells across the globe. And the original design was to use a background task, a periodic timer task, to go through and do that for us. And after some discussion, we found out that really, if the user's not looking at the app, it has no need to know that get that updated information. And we can do it whenever the app is actually running. So we push the timer to the app, actually inside of the app itself. And when the user's running the app and looking at the app, we will periodically update it. And anytime the app is resumed, we use that resuming event, we fire it. But we did not need the background task in that instance. And the other, is there a different approach? So the goal here is to make your app responsive to the user and for the user to feel like your app is doing something when they're not there and not using it, to give them that always connected, always on experience. There's other ways of pulling this off, primarily with toast notifications and live tiles. There are mechanisms using Windows notification services, using scheduled approaches, that you can update these live tiles or send toast without ever having to actually create a background task. And so if you do that, the user will still get the feeling that your application's on. You can still do all the kind of great, inform the user of if there's a new email that's come in. You can send a Windows notification service to the device to update the live tile to let them know that they have a new email. You don't have the app hasn't downloaded the email. It doesn't really matter. All the user's concerned is they've been informed that something's going on. So you need to consider that type of approach whenever you're looking at your architecture. You do need to be aware of your system resource constraints. They are hard and they will blow up and fail your background task. If you blow that 1 second CPU timer, at 2 seconds if you're on the lock screen, if you blow that metered network connection, it will fail off your background task. So you need to be aware of that and not write something that's going to continuously fail because it does you no good, because your background task will never run. And you have to plan for the lock screen. And it gets challenging. So you've got two types of apps, right? You have developers that are building the consumer apps. And if your app needs to be on the lock screen, you have really very little things that you can do because you want the experience to always be good for your users. So you can't hound them, right? So you ask them to add your app to the lock screen, great, they add it, or they don't, or they go in and they remove it later on. Your app still needs to function. You don't need to throw up a big sign that says, hey, dummy, go put me back on the lock screen or I'm not going to work. You need to be able to function without it. Maybe at a limited capacity, but you need to design it accordingly. Now, if you're building a line of business, you're doing a side-loading app, or you have a direct user base, you have more control over that, right? You can tell the user that, hey, you need to add me back to the lock screen for me to work, and that's okay, because you have more of a direct relationship with your developer. But you need to plan for that, and your app still should function and still work well, even if it's not on the lock screen. All this information is available. MSDN has got a ton of great examples of using all of these trigger types. Channel 9's got a ton of information. I know we're all here at TechEd this week, but we've got build going on in the U.S. right now, and there's tons of development stuff being pushed out on 8.1, so I encourage you to go check that stuff out. Probably all see this. For our speakers, the reviews are very important, so I would encourage you to go fill those out. I will be around for a while. If anybody has any questions, feel free to come down and talk to me. Other than that, I appreciate it, and I hope you have a great rest of TechEd.